All right, today we are doing 1.5 applying equations at day 1. Okay, you'll notice a little bit about that in a second. So we're talking number and angle relationships. Okay, so in our objectives, we are going to focus on the first objective today, which is solving problems involving number and angle relationships. This is day 1. Day 2, we're going to spend 4 days on this one lesson in the textbook. Okay, so day 2, we're going to be looking at the distance formula. Day 3, simple interest formula. Day 4 is involving mixtures, problems involving mixtures. So there's a lot to this section that they just throw all in. We're going to slow it way down. Okay, the other thing you're going to notice in your homework tonight, you have some even problems to do. Don't fret. Okay, those are, I actually have the answers for the evens on the back side of your homework. And we'll look at those today. So I want you to do all of these problems and 37 through 45 odd. Okay, but I do want you to do the even ones today that I've listed. All right, so first of all, because we're doing problem solving, we're going to look at the problem solving steps just to review. The first one is to read. Okay, you want to carefully read your problem, find any keywords or phrases so you can figure out what type of problem you're doing and solving for. All right, then we're going to, step 2, make a plan. So organize the information in some way that makes sense to you. It could be a table, a picture, a diagram, whatever. I do a lot of that, and I try to model that for you as well, and how I walk myself through that. Step 3 is solve. You have to write an equation representing the relationship, okay? So that's a big one, is writing an equation or equations, plural. Sometimes there's more than one. And check is to relate the solution to the problem. You know, sometimes checking, especially if you're working with someone as simple as asking, like, did you get 16 for this? Like 16 feet? Okay, and sometimes it's going back and checking the problem, putting your number in and checking your math and things. There's different ways to check, and we do lots of different ones too. So read, plan, solve, and check. Okay, so now we have some helpful equation writing tips, and these are super helpful. Okay, so if you're looking for, if you're given a problem that says they're consecutive integers, you're going to write n, and then the next number would be n plus 1. And the next number would be n plus 2. And then n plus 3. So say n was 4. Okay? So see, n would be 4. N plus 1, so 4 plus 1 would leave you with 5. N is 4, so 4 plus 2 would give you 6. N plus 3, 4 plus 3 would give you 7. So I'm getting a list of consecutive integers by using that notation. Okay. You might also have a list that says consecutive odd or even integers. So in this case, you're going to have your n, which is your starting number, and then the quantity n plus 2. And then the quantity n plus 3 would be next. So again, if I look at 4, say n equals 4, so n would be 4. N plus 2, so 4 plus 2 is 6. 4 plus 3, oh, I put 3 there, that's a typo. I'm sorry, should be 4 plus, or n plus 4 here. Because then 4 plus 4 would be 8. And your next one would be n plus 6. So 4 plus 6 would give you 10. Now the really cool thing is that this works for even or odd numbers. So say n was 3. Okay, so then we'd have 3 for our first one, n plus 2, 3 plus 2 is 5. N plus 4, 3 plus 4 is 7. N plus 6, 3 plus 6 is 9. Okay, so that pattern works if it's even or odd because it's based off of your initial integer, that n. Okay, next up is the measure of the supplement of an angle with a measure of a degrees. So supplement equals 180 degrees. You'll need to know that. But you would do 180 minus a because it's however many degrees there are. If it's the measure of a complement of an angle, okay, it's going to be 90 minus 100, or minus, it's going to be 90 minus a because complementary angles are 90 degrees. And the last one is a ratio. A lot of these problems you're going to be given a ratio connection. So maybe it says the length and the width have a ratio of 7 to 5. Well, you're going to change that and write it as 7x and 5x. And that'll make a little bit more sense probably once we start using it. So best thing is to just jump right in with both feet. In example 1, we have the footprint of the Lincoln Memorial is a rectangle. All right, that's helpful. Okay, I'm reading for information right now. Determine the dimensions and the area. Okay, these are the things we've got to find out. If it's perimeter, there we go. So perimeter is 160 or 620 feet. So I'm going to go ahead and write P equals 620 feet. And its length to width ratio is 19 to 12. Okay, so length to width ratio is 19 to 12. So I'm going to put length to width equals 19 to 12. Okay. All right. So I've read it for my information, right? Okay. We know it's a rectangle, so I'm going to draw a rectangle of my Lincoln Memorial. It's footprint, right? That's what we're trying to decide. Okay. So we know its perimeter is 620 feet, and we know perimeter is the length plus the width, right? It's the length plus the width, and we multiply that by 2. But we don't know the length and the width. Okay. So we do know the length to width ratio is 19 to 12. This takes us back to this part right here. When we have a ratio, we can just add the x to it and split them up. So in that case, since it's length to width, our length is going to be 19x and our width is going to be 12x. All right, well now I actually have a length and a width, so I can take those and put them into my formula here. So my perimeter is going to equal the quantity of 19x plus 12x times 2. So 19 plus 12, all right, is equal to 31x times 2, which is 31 times 2 is 62x. All right, my perimeter is 62x. But I also know that my perimeter equals 620 feet. Okay, so I need to put those ideas together. Okay, so 62x, I'm going to bring that up here, is my perimeter, but so is 620 feet. So I can solve for x. Divide by 62, and x equals 10. All right, I'm going to circle this. It's kind of my intermediate answer, because it's asking me for the dimensions and the area. X is not either of those things. But I can find them. Okay, now that I know x, I can find my length and my width, and then I can calculate the area. So yes, there's a lot of work to be shown in these. I know that some of it you could probably do in your head. I get. But I want to see how you're getting the parts. Okay? All right, so then our length, right, is 19x. That's what we found out over here. And we know x is 10, so this is going to be equal to 19 times 10, which is 190 feet. And our width is equal to 12x, which is 12 times 10, so 120 feet. So we just found our dimensions. Check. Now I still need to find the area. How do I find the area of a rectangle? Good. Length times the width. So area equals length times width. So my area is going to be 190 times 120. And that equals 22,800 feet squared for my area. So we just finish the problem. So we found the dimension and we found the area. Excuse me, I'm getting ready to sneeze. Pardon me. I moved my microphone, so hopefully it wasn't too loud. Okay, so we're walking through these multi-step problems today, which is why we're spending 4 days on this section in the book, because it's a lot. Okay, so let's look at example 1.2. It says find the measure of 2 supplementary angles that are in the ratio of 1 to 4. This might feel familiar to you since it's what we did all year last year. So we've got 2 supplementary angles and a ratio of 1 to 4. So supplementary, if you recall, is that straight line. They form a straight line and we've got 2 angles in there. The ratio is 1 to 4. So remember, that's 1x to 4x. Well, where can we go from here? What do we know about supplementary angles? Good, they add to 180 degrees. So we could say, write an equation that says, well, 4x plus 1x has to equal what? Good, 180 degrees. And then we can solve it. So 4x plus 1x is 5x equals 180. Divide by 5. And x would equal what? Good, 36 degrees. All right, so again, kind of an intermediate answer because it wants to know the measure of 2 supplementary angles. Well, that's actually one of the angles, right? 1x, angle 1x is 36 degrees. Angle 4x is going to be 4 times 36, which is how many degrees? Perfect, 144 degrees for angle 4x, and then 36 degrees for angle x. And you can check those quickly. Is 36 plus 144, does that equal 180 degrees? Yes? Then you've done it correctly. Okay, they don't always have to be long, drawn-out checks. On the back side, find 3 consecutive odd integers whose sum is negative 75 degrees. So we want 3 consecutive odd integers. Sum, which means addition, right, is negative 75. So what was that helpful tip if we had odd integers? What pattern did we use? Good, we said, all right, so we're summing them. So n plus the quantity n plus 2 plus the quantity n plus 4 is negative 75. All right, then we're ready to solve it. So we can combine our like terms, right? N plus n is 3n. 2 plus 4 is 6. So 3n plus 6 equals negative 75. Now we need to balance and solve. So we're going to subtract 6. We'd have 3n equals negative 81. What will we do next? Good. Divide by 3. So n equals negative 27. Well, now that we know n, we could check n plus 2, right? So n plus 2 is going to equal negative 27 plus 2, which would be negative 25. And our n plus 4 quantity would be negative 27 plus 4, which would be negative 23. So our consecutive odd integers are negative 23, negative 25, and negative 27. Okay, but again, we wrote the equation. We picked out the important information, kind of came up with a plan, wrote an equation, and we solved. That pink doesn't show up super great, does it? All right, so let's go to example 1.4. All All right, Gabby is twice as old as Casey. All right, so twice as old as Casey. Casey is 4 years younger than Tyler. The sum, so addition, of their ages is 24. Find their ages. Okay. Now, it's helpful to note, okay, is that both of these people, Gabby and Tyler, are being talked about in terms of Casey, right? Gabby is twice as old as Casey. Casey is 4 years younger than Tyler. Or we could say Tyler is 4 years older. We might say Tyler is 4 older than Casey. Okay, we might change it so it's easier to see how they're in terms of Casey. So that means, what that means though, is that K is going to be our variable for Casey's age, okay? Because Gabby, we'll say Gabby, is twice as old as Casey, so she's 2 times as old as Casey. Okay, Tyler is 4 years older than Casey, so 4 older would be 4 plus K. And then we have Casey's age. So we've got Gabby and Tyler and Casey, but Casey is the connection. She's the relationship. She's the one relating all of them together. Okay, so hopefully this is making sense. All right, then we know the sum of their ages is 24. So Gabby's age plus Casey's age plus Tyler's age equals 24. Well, it doesn't help us to have 3 different variables. We all need them in the terms of each other. So we're going to replace Gabby with 2K because she's 2 times as old as Casey. We're going to leave Casey's age, and Tyler's age we're going to replace with the 4 plus K. Okay, so breaking them down a little bit. Now, they all have a variable of K, and therefore we can solve them. So 2K plus K is 3K, plus K is 4K, and then we have plus 4 equals 24. So we're ready to solve. Subtract 4 from both sides. 4K equals 20. Divide by 4, and K equals 5. Okay, so Casey is 5 years old. We can find Gabby's age, right? Gabby is twice as old as Casey, so she's 2 times 5, which is 10. Tyler is 4 years older than Casey, so that's 4 plus 5, which is 9. So Casey is 5, Gabby is 9, and Gabby is 10. Pardon me, I got those backwards. Gabby is 10 and Tyler is 9. Okay, so this is what you're doing in your homework. You're working through these word problems and showing work on how you get them fixed. Okay, let's do that last one. Example 1.5. All right, Andrew ran a 56-minute 10K while Thomas took 62 minutes. Find their rates. Okay, so we've got Andrew, we got 56-minute 10K, Thomas did 62 minutes. We want to find their rate in minutes per mile. So minutes per mile. That's kind of hard to read, I feel like. Yeah, you can't read that at all, can you? Goodness. So min per mile. There we go. And it says use 1 kilometer equals 0.62 miles. Okay, I don't know if you guys remember unit multipliers. You've used them in Algebra 1, not so much in geometry. You should have used them in math class quite a bit. So this is a place where they'd be super handy. So let's look at Andrew first. Okay, Andrew ran 56-minute 10K, right? K stands for kilometer. And Thomas then ran 62 minutes for his 10K or to run 10 kilometers. All right, now, why I say a unit multiplier? Because we know 1 kilometer equals 0.62 miles. If you remember, a unit multiplier is a fraction that we use to cancel out and change the units. We want to get rid of the kilometers. So we need, kilometers is currently in the denominator, so we need the unit multiplier that has kilometers up here. So 1 kilometer is equivalent to 0.62 miles. Okay, and then our kilometers would cancel, and we would have 56 times 1 is 56. We have minutes is the only unit in our numerator. Per 10 times 0.62 is 6.2, and miles are the units in our denominator. Okay, oh, MI. And then we can reduce that. So 56 divided by 6.2. You all are Algebra 2 students. You are welcome to use calculators, right? You don't have to do this in your head, but you can. So that would equal 9 minutes per mile for Andrew. All right, we're going to do the same thing for Thomas. We're going to multiply by the unit multiplier. Kilometers, I'm going to explain this again, because we're using these values. 1 kilometer is equal to 0.62 miles. Okay, so we want kilometer in the numerator, so it cancels with our kilometer in the denominator. So we know 1 goes with the kilometer, and then 0.62 goes with the miles. Our units cancel for kilometers. 62 times 1 is 62. Minutes is the only unit we have in our numerator. Per 10 times 0.62 is 6.2, and miles are the only units we have in the denominator. So 62 divided by 6.2 is 10 minutes per mile. And that is for Thomas. Let me also say, like this would be, you could write it as 10 minutes over 1 mile. Okay, I'm just shortening that to the 10 minutes per mile. Okay, again, so here, this is kind of new. Since I'm assigning you even questions, I wanted to go ahead and give you the answers. So the answers for 2, question 8, and question 10 are there for you to check as well and make sure that you're doing them correctly as you're working through tonight. All right, have a great night. See you guys tomorrow.